from Wolfram alpha. Actually, if you remember, Wolfram alpha is the one I like the best for finding roots of a polynomial. So, if you want to write down this, so for example, okay, this has the image. Let me change to something that is not an image. Okay, let me give you something. I guess it has.
They're like 3.5 or something weird.
There we go. So, and you can get it in SRX. Okay, so Wolfram alpha is a tool you can use to find the roots. Okay, and if a root appears twice, then, okay, here is one I will have.
I think you need a times in the game.
Oh. Oh. Okay, that's not the one I want to give as Q. Anyway, let me make the one I want to give. We'll eventually find it. Anyway, so that's the one I wanted to show you something we have multiplicity. So look at this one, for example. Okay, find it. So a little bit fast. There are also other tools, but the Wolfram alpha is an MU successful.
What does result false mean?
I don't know.
Not sure. There are no roots.
I think it's trying to find approximate first and cannot find the approximate. So it's going to full beyond now.
Maybe because the first question.
Huh?
Oh yeah, the first.
Oh!
So it thinks there's two variables.
What did I do? Okay. Oh, I had a typo. Thank you, Dan. That's what it means. There we go. But it didn't give you the multiplicity here. Okay. I didn't give you the multiplicity. Oh, I put a 3 here. Wait a minute. That, yeah, 0 has multiplicity 3. give you the multiplicity. Let me do an S cube here. Change this to 1. Anyway. So this one, how does it give you the multiplicity? There's two distinct roots. That's not what I want. No, that's not what I want. So give the multiplicity to realize that. So you have to figure out the multiplicity. All right, anyway, let's get started now. I just wanted to show you this, how you find the roots of polynomial 1, okay?
Okay. Yeah.
You
I
can
hear
use
you.
that too.
What about the multiplicity?
Huh?
What do you do about the multiplicity?
Yeah, you wouldn't be able to figure it. I'm sure someone here, if you look at the vocabulary, someone would be there. Clearly, you need 5 roots in 6th order. This one has clearly S cube is a factor. So
Yeah.
what you have is 0 is multiplicity 3 and minus 1 is multiplicity 2. I took S squared plus 2S plus 1 and multiplied by S cube.
This one's obvious.
Yes. They changed. You see that better? That's not the one I used before.
Yeah, you gotta pay for it now.
Huh?
You gotta pay for it now. You gotta like download it and stuff. It still works, but it's just crappy.
Okay, what's the other two you can use? Alright, let's move on. Alright. So let's talk about the quick and easy method. So the quick and easy method is for all CI. So I'm encircling the ones that are for quick and easy. So this is for quick and easy. This is for quick and easy. This is for quick and easy. In our example, how many are for quick and easy? Both of them. This is the highest power of root 0. This is the highest power of root 1, root 2 highest power. Right? If I have multiplicity 1, I get the only coefficient. So both of these are quick and easy. So we can do this example completely with quick and easy. So let me explain what's behind quick and easy. And by the way, I can tell you immediately C11, just by inspection, is 1 over 0.111. C21 is 1 over minus 0.11. It's that quick and easy. I don't even need to write anything. I can immediately tell you the answer. It really is quick and easy.
Did I mix it? No, I mean.
Okay. So I need an abbreviation for quick and easy. Since I don't like ampersands, how about QAM?
Just call it Quickie. Yeah.
Quick. Oh, QAM. Too much on the last. QAM. Or QE. Quick.
Quickie. There you go.
Let me first give you called in the final answer. The final answer is going to be simply CI is equal to hiding.
Hiding.
Yeah. Evaluating that's what it boils down. So what I'm saying here, I'm going to take this equation. If I want to do C2, all I have to do is look at the left-hand side, hide the denominator of C2, which is S minus R2 to the C2. With me? One?
Yeah.
Okay, so I want to find, let's say, C2. What's the denominator of C2? S minus R2 to the C2. So I go to the left-hand side, I hide this denominator, and then I use for S equals R2, and that's my answer. That's all it is. Hmm?
You multiply two.
No, I don't have to multiply anything. No multiplying through, guys. This is really easy. All I have to do is hide this and put S equals R2. So the answer for this C2 would be Bm R2 to the m plus B1 R2 over R2 minus R1 to the C1 R2 minus R2 to the C2. Immediately. I don't have to do anything else. It's that easy. Much easier than matching coefficients, guys.
Can you write it? Cause
Yeah, and I will do example.
That's fishy.
This is yes. So we hide the left-hand side of the denominator of what I'm finding. And we evaluate S equals 100. That's what it boils down to. E.g., here, I write an example. E.g. C2 is equal to
EG example. What's EG example? I think so. What's EG? Example? Okay.
I don't know the Latin, but it's very commonly used in English. For example, anybody knows the Latin origin of EG? Don't know. Okay.
Is it quickie?
It's the most powerful thing in the world.
That's the answer immediately. Okay?
It's simply gratia. It's simply gratia.
Example gratia. Okay, thank you. Thank you, Felix.
Um,
So example gratia. All right. That's really easy, right? So how do we get it? Here's the explanation. I don't need to explain, so I'll just give you the magic. Let's multiply both numerator and denominator of equation 411 by the denominator of the one I want to find. Okay, I multiply both sides of this equation here, of this big equation, the factor form equals that, by the denominator of Cix here. Left-hand side, since I multiply by that denominator, will be the same, except the Cix S minus Ri will be gone. In other words, what's that denominator? It's S minus Ri
Is that 4 minus 11?
to the xi. That's the denominator, multiply both sides of that equation.
Is that 4 minus 11?
Wait a minute. I multiply both sides
And what's
of 411 by the denominator, if I want to do C2 xi2, by S minus R to the xi2. Yeah.
What's 411? Oh,
What? Multiply both sides by 411?
No, what does it say? By the denominator of CI. What's the denominator of CI? Is here.
Okay. I see what you did. That was confusing.
E.g. S minus Ri to the C. Example Gradia. No, actually this should have been I. That's wrong. Should be I. Felix, you can find out what I stands. That is. That's not an example, that's I. E.g. for example, I is that.
are you making that up?
Is what?
No, I'm just asking. I don't know.
No, I'm not making that. You can look at that.
That's fine.
So what happens if we do that? The left hand side will be Bn Sn plus B naught, and the part I multiplied with gets cancelled from the denominator, so I will have S minus R1 to the C1, but S minus R I minus 1 to the Xi minus 1. I will skip the Ri because if I multiply with S minus Ri to the Xi, it got cancelled. So that doesn't exist. So the next one is Ri plus 1 to the Xi plus 1. And so on. S minus R2 to the Xi. So that's what left on the left hand side. Basically, I canceled the S minus Ri to the Xi. With me? Since I multiplied by that, I canceled it from the denominator.
That dash in between this last two terms, that.
Okay? Basically, the term that I took out, I took the S minus Ri to the Xi out. Clear? And the right hand side, I'll have S minus Ri to the Xi multiplying everything here with cancellations. This will be the Ci will have the denominator cancelled, but everything else will stay. So the right hand side will have Ci, since I multiply everything by its denominator, that's the only term left. And everything else will have S minus Ri to some power, at least one power, times all else. Quick example, let's. I get it. Well, no, I better not erase. I don't want to erase this part, but I will erase and go with. Let me give you a quick example by what I'm talking. Yeah, let's do another example.